In this video, we'll explore why it is easy to multiply by multiples of 10. Now, if we think about our base 10 system and our decimal system, it is all based around our ability to multiply by 10 and its ability to shift our place values as we multiply by 10. Let's look at an example here where we have 10 times 12, and I'm using base 10 blocks to help out. By saying 10 times 12, that means we have 10 groups of 12 blocks. Now, if I group my blocks, I can say that I have a group 10 tens, I have another group of 10 ones, and another group of 10 ones. This means that I have one group of 10 tens, which is 100, and two groups of 10 ones, which is 20 or 120. Now, if I look at that number, I say, well, what do I notice? Well, I've taken 12 and I've shifted my place value for each digit one place to the left by multiplying by 10. And that's a great rule to help us when we're multiplying by 10. We can think about it as if we're saying we multiply a number by 10, we're shifting the place value of each digit one place value to the left. So say I've got 10 times 192. I'm going to take my 100. It now shifts to the thousands. I take my 90, it now shifts to the hundreds, and I take my 2, and it now shifts to the tens, which means I need another place value here. Since I have nothing in my ones place, I would put a 0. So that 192 is really 1,920. And you may find it helpful as you're teaching your students to actually keep the decimal there to help with that understanding of shifting place values. So that you see, oh, I got to shift a 0 into that ones place if there was nothing before that. Let's look at, well, what happens if we're dealing with decimals. Well, it's the same idea. We're going to shift our place values one digit each left. So 10 times 25 thousandths, well, my ones place value now shifts to my tens, my tenths now to my ones, my hundredths to my tenths, and my thousandths to my hundredths. So 25 thousandths times 10 becomes 25 hundredths. And if I really wanted to, I could put a 0 here, and I would recognize that that's 250 thousandths, which is equivalent to 25 hundredths. Now, what about if we have other powers of 10, such as 100, 1,000, 10,000? Well, our shift will still occur, but it's based on that power of 10. So here I have 284 times 100. Well, what I can think to myself is, what's that power of 10? And if I can write this as 284. Well, 100 means 10 times 10, which, as we learn later in our classes, as our students move to middle school, that we could write that as a power of 10 squared. But that 10 times 10 as our representation of 100 tells us that that means we need to shift two place values to the left. So that now 284, I would shift the 200, now goes to the 10,000s. The 80 now goes to the thousands. And the 4 now goes to the hundreds, which means I then need to include two zeros so that 284 times 100 is 28,400. It is still very similar when we're dealing with our decimals. Here, though, another thing we can teach our students is that we can take our decimal place. Here it's telling us that we're multiplying by 10 squared, which is, if we remember again, that that's 10 times 10, that means we're shifting two place values. So as I can shift my place values to the left, my decimal shifts to the right. So I could say that instead of shifting the place values, I'm going to move my decimal one place value, two place values to the right. So 3 and 45 thousandths times 10 squared would mean times 10 times 10 or times 100 creates 304 and 5 tenths. Now, as you get into middle school and high school math, you start to deal with what are called negative powers as well. And this is just like dividing by powers of 10. So we got to think about, well, what does that do to our place values? It still only shifts them based on that power of 10. Just this time, it'll shift them to the right. So when we think about 284 times 10 to the negative 1, that would be equivalent to saying 284 divided by 10. So from there, I can say, well, that means that I'm going to shift my place values one place value to the right. So the ones goes to the tenths, the tens goes to the ones, and the hundreds is now in the tens. So now 284 times 10 to the negative 1, or 284 divided by 10, is 28 and 4/10. So what if we have decimals in our number as well? Doesn't matter. We can still work with it. Say that we have 3 and 45 thousandths times 10 to the negative 2. That would mean 3 and 45 thousandths divided by 10 divided by 10 again. So we're dividing by 10 two times, so we're going to shift our place value for each digit 2 digits to the right, 2 place values to the right. So my 5 in the thousandths will go to the hundred thousandths. My 4 in the hundreds will go to the 10,000ths. My 0 in the tenths will go to the thousands. And my 3 in the ones goes to the hundredths. And what I do there is I then will put a 0 in my tenths and a 0 in my ones place to help recognize what number do I have, which is 3,045 hundred thousandths now.